Your facade has 200 panels. Panels within 5 meters of the entrance should be glass, open, inviting. Panels beyond that should be solid, heavy and secure. How do you tell Grasshopper apply two different rules based on one condition? One component makes this possible, dispatch. One concept, analyze it, Boolean logic. Let's learn both.
First, a quick reminder of what a domain actually is. Simply a range from one number to another, 0 to 100, minus 10 to plus 10. Place a construct domain component from the Math tab. It takes starts A and an end B and outputs a single domain. You'll use domain constantly as inputs to remap, as slider ranges, and to describe a surface UV space, which we'll get to in day 13. Now, let's build a comparison. Place a point grid or reuse the 6x6 grid technique from day 10 with craft. Place a single point elsewhere on the canvas to act as your attractor. Right-click it and choose set one point, then click any location in the Rhino viewport so you can move it live later. Place a distance component. Connect the grid points to A and attractor points to B. This outputs 36 distance values. Place a larger than component from the Math tab. It compares two values and outputs true if A is greater than B, false otherwise. Connect the 36 distances to A input of larger than. Place a number slider named threshold, range 0 to 20 to B input. Read the output. 36 true or false values. Points far from the attractor, distance greater than the threshold, come out true. Points near out comes false. Now place a dispatch component from the sets tab. It has two inputs, L, the list to split, and P, the Boolean pattern that decides where each item goes. Connect the 36 grid points to L, connect the larger than output to P. Dispatch gives you two outputs. A holds every item where the pattern was true, our far points. B holds every item where the pattern was false, our near points. Place a center box component. It has four inputs. B, the base point or plane where the box is centered, and XYZ, the box width, depth and height. Connect the A output of dispatch, our far points, into the B input of center box. Grasshopper automatically treats each point as the center of the world aligned plane, so you don't need to convert it manually. Place a number slider named large size, range 0.5 to 5, default 3. Connect its output to the X input of center box. Now drag that same wire to also connect into Y and again into Z. One slider, 3 wires feeding all 3 dimensions so the box grows as a cube rather than a flat slab. Now repeat this for the near points. Place a second center box component. Connect the B output of dispatch, our near points, into its B input. Place a second number slider named small size, range 0.1 to 2, default 0.5. Connect it to that center box XYZ inputs the same way. One slider, 3 wires. Move the attractor point in the Rhino viewport. Watch the threshold boundary shift. Boxes flips between the large size cube and a small size cube live as their distance crosses the threshold. Adjust the threshold slider itself. A low threshold means almost every panel reaches as far, mostly large boxes. A high threshold flips that, mostly small. The threshold becomes a direct design control. What if you have two attractors and you want any panels near either one to respond? Place a second attractor point and repeat the distance too smaller than chain against the same threshold, producing a second true or false list. Place a gate or component from the Math tab. Connect your first true or false list to A, your second to B. Gate or outputs true if either inputs is true. Feed that combined pattern into dispatch. Now any panel close to either attractor is treated the same way. The flows into the same center box chain we already built.
Summary of this video. What we learned. How to build a domain explicitly. How larger than and smaller than converts continuous measurements into Boolean values. How gate or combine multiple conditions. How dispatch turns a Boolean pattern into two separate design outcomes. And critically, which of Grasshopper's 4 box components actually accept a single center point? Center box. Components used. Construct domain, distance, larger than, smaller than, gate or dispatch, center box. Key takeaway. Boolean logic is the bridge between a continuous measurement and a design decision. Dispatch is the component that acts on that decision. And center box is the component that turns each resulting point into visibly geometry sized by your rules. Every grid you have built so far has been flat. Next time, we curve it. Day 13, UV space. The coordinate system hiding inside every surface and how it lets you place geometry perfectly on any curved form, no matter how complex. See you in the next one.